Hey there, class, and welcome to another week of chemistry. Excuse my uniform, I just got off work, and so I'm doing this next presentation here in my work uniform. It's kind of dirty. But this week, we're going to be doing an iodine clock reaction, which was something that was actually discovered in I think it was 1880s by a scientist, and there's a couple different variations of this reaction, but um, you know, we're going to use all the essential ingredients here, and really the only variation that I found was what sort of acid you end up using. So I don't happen to have so what is it? H2SO4, hydrosulfuric acid, sulfuric acid, I should say, at my home, but we do have vitamin C, and vitamin C is also known as ascorbic acid, so it is an acid and should, in theory, work. So I'm going to start kind of mixing these kind of solutions. I've already got some of them prepared. Do some finishing touches, and we'll see what kind of happens here. But in this one, I'm going to go ahead and caution you. This one is, I'm going to show you solution A here in a minute, is vitamin C tablets, about 2 grams crushed up and mixed with some water. Now, what would be nice is if the tablets were colorless. I didn't know when I bought these, but they were actually orange in color. So we're got an orange solution here, so you might end up with a different kind of reaction here at the end, but that's okay. So that's in solution A is just some water and some vitamin C. We're going to add some iodine to it here in a minute. In B here, we have some cornstarch, which is just a kind of a thickener here. Water, and about 150 mils of hydrogen peroxide, and we're going to combine these two. So I'm going to go ahead and add some iodine, and this is iodine I got from here from work, and this is actually used in a clinical setting as an antiseptic, but it says here on the bottle this is equal to about 1% iodine. So we're going to use probably about 80 mils or so, maybe 100. And we're just going to add this. There's about 120 in this, and so the reaction calls for about 25 milliliters of 5% or 60 milliliters of 2%, and I've got 1% here. So we'll use the majority of this here. Oops. There we go. And so you see that this is very brown, but when you add it in, it kind of loses its color, and it's due to the vitamin C. So I think we're still going to get a reaction out of this as we intended. We just might get different colors than what we're expecting. And hold on, I'm going to step back here because this iodine stains very well. So we've got a little bit left in there. That should be good. So you can see that we've got still an orangey solution, still what is mostly vitamin C. So we know that we have enough vitamin C in here because when we add our iodine, you might see an initial color change, but if there's enough vitamin C in there, then it'll go back to the original vitamin C color. So we're going to top this off with a bit more water here. That should be good. So we've got some more water in here with our vitamin C, our iodine, and our, yeah, I guess that's it. So iodine, vitamin C, and water. So we're going to place it into this container here, and hopefully we get a quick reaction here. We're going to find out. So I got it in this right here. And we've got our cornstarch, hydrogen peroxide, water mixture here. I'm going to go ahead and pour this in. Didn't get quite all of the cornstarch that we wanted in there, but we got most of it. And so what we're kind of looking for is a color change in this solution. But again, it's going to be hard to know with my colored vitamin C tablets. But let's see here. Let's go ahead and pull up this equation. So if you can see there, so there are two kind of competing reactions there. We've got a slow reaction and a fast reaction. And so the vitamin C is competing there, and that's the quick reaction. So when that runs out, what should be colorless, or our orange, is going to then change to the slower reaction as the vitamin C gets consumed. So let's see, let's flip back here. And we'll see what happens, see if we can get a good kind of color change here. So as far as speeding this up, there's a couple different things one can do. I guess the first would be heating everything up. Adding heat to a reaction can increase collisions and thereby speed up chemical processes. We can use increased concentration of reactants, and obviously the other kind of big thing is just getting rid of impurities. So ideally with both reactions, or both solutions I should say, we would have really done an excellent job of filtering out impurities that we just don't need. So for instance, when we did our vitamin C tablets, actually we can start to see the color change now. There we go. Beautiful. So, we would take our vitamin C tablets, and there's a lot of other kind of ingredients besides vitamin C that go into those tablets. So we would get rid of some of the excess particles with that. With the cornstarch, again, we could have heated that up and really made sure that that mixture was good, and we got rid of any excess cornstarch that just wasn't being used. But we definitely achieved our goal reaction there. We definitely saw this orange go to a more brown. Ideally, we would have colorless to blue, but again, we started off with a different color than colorless. So we definitely had a color change is what we intended to have happen. So this was a successful reaction here. So we will see you again next week for some more science.